All aboard, we are going to ride the mole train as we solve these problems here. And this is from page 8. So I'm doing a couple example problems of your homework packet. So first one says calculate the following in grams, and there's a series of problems, but the first one is 0.43 moles of Cu. So I'm just going to identify what I know, what I'm trying to find out, and then go ahead and solve this problem. Let's see. So 0.43 moles is what I know. That's where I'm starting with. So I'm going to say that's my moles. That's my starting point. That's what I'm given. Okay, I could even come over and write this in here like this and say 0.43 MOL. Okay, so that's my starting point. Okay, what am I trying to get to? It says calculate the following in grams. Well, grams isn't atoms or molecules, grams is a mass. So this is where we're going to try to go with this, is to go from moles, and that's supposed to be a question mark there. That's our destination. So we're going to go from moles to grams. Now, what does the mole train tell us? It tells us to multiply, so I'm going from left to right here, by the molar mass. The molar mass of what? Cu, because that's what I'm using in this equation. So what I'm going to do is look up the molar mass of copper, because that's going to be my next step. And I got to grab my periodic table, and I will do that right here and scroll down. Here we go. I see Cu. Okay, and it looks like it's about 63.546 grams. I could round that to 63.5 grams. So I'm going to bring that number back up and work with that right up here. Okay, that looks like where we're at. So we said it was 63.5 grams, or with two figs, I could round it to 64. Either way is fine. And what I think I'm going to do is put a times sign here, and where I come from goes on the bottom. So I'm coming from moles. Moles goes on the bottom, MOL. And what's the mass? We said it was 63.5 grams. So that's supposed to be a decimal. And then 5 grams. Now notice it's 63.5 grams per 1 mole. How do we know that? By definition, the molar mass of copper is 63.5 grams. This means there's 63.5 grams in 1 mole, not the opposite way. Note when you do a conversion at this point, when you do molar mass, it's how many grams, which you don't know, per 1 mole. So it'll always be 1 mole when you do this moles to grams or grams to mole conversion right here. So is that it? I converted from moles. My moles cancel out. I'm at grams. I just have to multiply that through. And if I carry that through, take a look here, make sure we do this right. I think you get something like, okay, 27.2 or just 27 grams of, if you want to say copper, you can. But do make sure you say grams, because it's asking for what's the mass, and then you'd say 27 grams. You could round it to 27.2, but with 2 figures, 27 would be better. Okay, so again, reviewing, I figured out where I was at. I figured out where I was going. I probably should have circled that. That was said, find the following in grams. That was what I needed to find. So I started with my moles. I multiplied by the molar mass. Whenever you multiply by molar mass, that will be different for every molecule, compound, or element you use. So you got to find that on the periodic table. I did that, and then I ended up with 27. Let's see if that answer makes sense. If I had 1 mole, it's going to weigh 63 grams. So this is a little bit less than a half a mole, so it should be a little bit less than half of 63 grams. And I think 27 grams fits in there pretty good. Can you have a half mole? Absolutely. It's a big number. And just like you can have a half a dozen, it's just a fraction of that really big number right there. That is number 1 on page 8. I think I'm going to scroll and do one more. Okay, we're going to clear this out. And this is, so if you look at those, there are a lot of them going from, in that first set, going from moles to grams. I think later on you get some going actually from atoms or molecules to grams. So you'd have to do that in 1-2 steps. Okay, let's look at problem number 2 and do one example from that. And scrolling a little far here, let's see, I think we got a mole train, and it says calculate the following in atoms. Now let's look at where we're starting and where we're trying to go. So I'm going to look at this. It says we have 4.3 moles. So that's going to be where we're starting again. But this time we're trying to find atoms, which means we're going to go this way, and this is going to be our unknown. Now, what's the difference between finding atoms or molecules? There's 6 times 10 to the 23rd atoms in a mole, or 6 times 10 to the 23rd molecules in a mole. There's also 6 times 10 to the 23rd pencils in a mole of pencils. So it just depends if you're talking about elements or compounds. This is an element, so that's why I said atoms. Okay, so I'm going to do that, and I'm going to write what I know, which is my 4.3 moles. I'm going to write that here, 4.3 moles. Okay, now my next step I'm going to do is I'm going to times that. And the trick here is I'm going from moles to atoms. So I'm going to put moles on the bottom so it cancels out. And I'm going to put atoms on the top. Okay, so I'm going to put atoms on the top. I'm just giving myself a little bit of room to write here. So wherever you come from goes on the bottom. Whatever you know goes on the bottom, which is moles in this case. And wherever I'm going to goes on top. So there are 6.0 times 10 to the 23rd, what, moles in an atom, atoms in a mole? Again, it's just like molar mass. It's always how many atoms per 1 mole. So when you're doing a conversion from moles to atoms, the 1 is going to go by the mole in this conversion. Just like when you do the molar mass conversion, the 1 is going to go by the mole in that conversion. And then what do? We put our 6.0, and I'm just going to use 2 figures because that's all I have there, so I don't have to mess with the 0.02. And then I'm going to say times, and then 10 to the 23rd power. Okay, I'm going to calculate that out and get an answer. And I think I get something like, I might just do this in text, 2.6. And sometimes you'll see this on your calculator, E, and it's going to be 24. Okay, and that would be the same as, if you see that, that is the same as 2.6. Whoops, I'll draw this in. Be a little bit slow. It's the same as 2.6 times 10 to the 24th atoms. And then that would be atoms right there. Pretty messy atoms. But 2.6 times 10 to the 24th atoms is the same as this right here. Okay, let's see if that answer makes sense. 1 mole is 6 times 10 to the 23rd. 4 moles is going to be 4 times bigger. So I should get a bigger number, which makes sense right here. Notice when you go from moles to atoms, it does not matter what substance you were doing. If I had 4.3 moles of copper, it would be the same number of atoms of copper. If I had 4.3 moles of eggs, it would be this number of eggs. So this is not dependent on the substance, this conversion. This conversion here is dependent on the substance. All right, there's a key, I think, for all of page 8. What that was just to talk through on a couple problems. Hope that helps. Good luck riding your mole train.